to a demonstration of parabolas. So here I'm using GeoGebra, and if you look down here in this bottom left hand corner, we have the most basic of parabolas. It's y equals x squared. Now if you look at the graph, we have a mirror line right through the y-axis. Remember, this is on a basic parabola, or the mother of all parabolas. It's got a turning point right at 0, 0, and it keeps going. Okay, now this is your basic parabola shape, or parabolic shape. Now, bear in mind that we've got one of the general equations of a parabola, which is y equals a bracket x plus b close bracket squared plus c. Okay, and this is where a, b, and c are real numbers. So, now if I just adjust the c value, remember that's our constant value, if I adjust it, now, I'm just going to increase the c value, watch what happens to the parabola. Okay, so I am adjusting the c value, and as I increase it, the parabola moves up, okay? Now as I decrease it, now as I decrease it, look at what happens to the parabola. Okay. It shifts down. I'll let it play again. So when c is negative, it goes below the x-axis. When c goes positive, it goes above the x-axis. Okay. I'll just stop that. Okay. So here we know if our equation changes. Let's see if I put it to c equals 1. Now, here you will notice that the turning point, so we've got the basic parabola plus a constant in the equation, okay? Now look at what's happened to our equation here. We've got x squared plus 1. Now look at the turning point on the parabola. Notice that that is at positive 1 on the y-axis. So our y-intercept is positive 1. Okay. Now, let's get rid of this so we can see what happens when we change our b value. Sorry, just trying to get 0. Oops. Sorry for this. Okay, so now we've got our basic parabola back again. Here's our equation. Here is our basic parabola. Remember, this is representing a quadratic equation. Now, if I've got b and it's x plus b in the bracket, when b is a positive number, let's see what happens, shall we? Watch what happens to the graph as I increase b. So remember, b is a positive number. B is still a positive number. Now, what's happened to the graph? So, as b increases, the more of a shift the parabola has to the left. So, the turning point actually goes into negative numbers for x. What happens if we make b negative? Which way is it shifting? It's shifting right. So when we have negative numbers for b, the parabola shifts right. Okay, now we've got our basic parabola back again. Now what happens if I change the coefficient in front of x? So that's the number in front of, x squared. What happens when I do this? Okay, so here our coefficient is equal to 1. So when our coefficient is equal to 1, remember in algebra we don't normally write 1 in front of our variables. So when our coefficient is equal to 1, we have our basic parabola. What happens if we increase this from 1? So here, as our a gets bigger, our parabola gets narrower. Cool. So what happens if I put it between 1 and 0? So we're at 1. Getting closer to 0, closer and closer to 0. Whoops. So as we get closer and closer to 0, our parabola becomes wider. Okay? So when it's positive, it's concave upwards. So it kind of makes a smiley mouth. Okay? So remember, caves go inwards. The inwards part of the parabola is pointing up. So it's concave up when it's positive. Right. When it is between 0 and 1, the smaller the number, the wider the parabola. The larger the number, above 1, the narrower the parabola. Let's see if that happens when it goes negative. What happens to the parabola when it's negative? Ooh, it is concave down. It makes kind of an unhappy mouth. It is concave down when it's negative. Okay, so here it is between negative 0. Whoops. Between negative 0 and negative 1. Let's see if we can make this move more smoothly. Okay, so similar thing like when it's in positives. The closer to 0 it gets, the wider it gets. The closer to 1 it gets, a negative 1, sorry, the closer to the original shape it gets, just concave down. Okay. And as we go above 1, above negative 1, it becomes more narrow again. Cool. So here I think we can find some generalizations. So if our coefficient, if our x squared coefficient is negative, then the graph becomes concave down. If it is between the closer to 0 the a value gets, the wider the parabola becomes. The larger the a value gets, or the more towards infinity, negative infinity, and the more towards infinity the parabola the a value becomes, the coefficient, then the narrower the parabola becomes. As our b changes, the b gives us our shift left or right. If b is positive, we get a left shift. If b is negative, we get a right shift. When c increases, the turning point goes up. As c decreases, goes negative, our turning point goes down. Okay, or our y-intercept changes. And that's it for our demonstration.